All right, indicator 7.1 is graphing linear equations. Some of this should be a little bit of review, which is kind of nice, okay? And then some of it will be using information from indicator 5 to then take the next step, which is graphing our linear equations. Remember, linear just means a line, so we're graphing equations that graph in a straight line. And straight lines are consistent as far as their either incline or decline, and that's what the slope is. So your slope is a consistent change in x or change in y over change in x, change in y over change in x, and as long as you stay with that consistent count, every point that you count up and over, up and over, up and over is going to land on your line. How many points do you need to graph a linear equation? Yes. 2. You only need 2 lines because or 2 points because it is a straight line. So this is a little bit of review. Okay, so this makes it nice, but we have already talked about intercepts in indicator 5. Intercepts, remember, they lay right on the x and the y axis, and this is your x axis here, x axis and your y axis, right? And so if you have the x intercept at +1, that means you go to the x-axis at +1 and you put a point. Then you have the y-intercept at +4. You simply go to the y-axis and on the point +4, you put your second point. And as long as you have 2 points, you can connect those 2 points with a line and arrows on each end because lines go on forever and ever. And then it's graphed. So graphing intercepts really is that easy. You just put your x-intercept on your x-axis, your y-intercept on your y-axis, and you connect the 2 points, okay? Now you only need one example in your notes. I'm going to go ahead and do a second example just real quick, just to run through it again, but you don't have to copy it down in your notes. So for number 2, if we have the x-intercept at -4, that means I'm going to go on the x-axis, and at -4, I'm going to put a point at -4. And then the y-axis is at -2. So, or the y-intercept. So I'm going to go to the y-axis, and at -2, I'm going to put a point, 2 points, and you're ready to draw a straight line connecting them. Okay. So graphing intercepts, it's pretty straightforward, pretty easy. Any questions on that? All right, so when we're graphing one like number 3, and I'll give you a minute to sketch that down in your notes. And when you're sketching these graphs, don't get too intricate. Just give yourself an X and a Y axis and a couple of slashes on each axis for points or for numbers. All right, so hopefully you recognize that number 3 here is in y equals mx plus b, okay? And this is just a refresher here, but in y equals mx plus b, your m is your slope, okay? You don't have to put this in your notes again if you already have it. We've done this quite a bit now. Your b is your y-intercept, okay? So if I was to ask you here, and I want you, anytime you do graphing and you have them in a different equation, or if you have them in a form, any form, I want you to get in the habit of stating your M and stating your B, okay? So here it's already in y equals mx plus b. So it's very easy to state the M. You simply go to the equation right here, right? Between the equal sign and the X, whatever that number is your M. So in this case, our M is -5/4. And if this was a whole number, you just simply put it over 1, because you do need a fraction, because you need a rise over run. So if it's not a fraction, make it a fraction by putting it over 1. And then your B is always this number at the end, including its sign, that's either a negative or a positive. In this case, it is a -4. When you're graphing in y equals mx plus b, this is just a little memory trick that I have. Write it down if you want, if you don't want to, but B stands for beginning. Okay, B stands for beginning, and M stands for move. because you are always going to do your B at the beginning. That's your first point you plot. And then you're going to use your M to move to your second point. Okay. So with that being said, we've already identified our M and our B, which I want you to get in the habit of doing. It's on quizzes and tests. It'll be worth a point. Okay. So make sure on your homework that you get in the habit of doing this right here, because that right there is worth a point on your quizzes and tests. Okay. So my B is my beginning point that I plot. So that means that on my Y-axis, because your B is your Y-intercept, I'm going to put a point at -4. That's my beginning point. Then I use my M to move. Okay. Now this is what's really important about your M. Your M, it does not matter. Would everyone agree if I was to say that, I'm going to put my M down here again, -5/4 is the same as 5/-4. Would everybody agree that those two are the same? When you're talking about moving on a graph, a -5 is a downward move and a +4 is a right move. Okay. Or looking at the bottom one, a +5 is an upward move, but then a -4 is a left move. Whichever way you do it, you still end up with a negative slope. What you don't want to do is go down and then backwards, because if you go down negative and then backwards negative, two negatives makes a positive, and we've changed it to a positive slope. So the reason I want to cover this is because looking at this graph, right, from my red beginning point, I don't have enough graph space to go down 5 and then to the right. So instead of going down and to the right, which would be a negative move, I'm instead going to go up and to the left, and it's still going to keep it a negative move. So I'm going to do this option, right? And you don't rewrite it with the negative on the bottom. As long as you make the move up and right, left, I'm going to know you kept it negative. So writing it like this up here, where I just circled or squared, that is fine to leave it like that. Don't feel like you have to rewrite it with the negative on the 4 if you're going to plot it different. You don't. Okay. But so I'm going to go +1, 2, 3, 4, 5. And then I'm going to go -1, 2, 3, 4. Notice I went up 5, or no, I didn't. I went up 4. Hang on a second. Let me fix that. I did it and then I changed colors and I messed myself up. Up 5, 1. I'm going to find a different program besides this note writer, just because it always pops that eraser in the spot and it drives me crazy. All right. So let me put my point back here. My point was at -4. All right, so I'm going to go up 5. 1, 2, 3, 4, 5. I went up 5. One of my moves has to be negative since that was a positive move. Backwards 1, 2, 3, 4. There is my second point based on my move. Notice I started with my beginning B, which is the red point. I used my M to move to get my second point. And once you have 2 points, then you just connect the two of them with a line. Now you do not need all of the arrows going all the different directions that I have on the graph. I put those up there because when I'm talking, you can't see where my eyes are going. So I'll put the arrows on there to kind of show you what my thought process is, but you do not need all of these and this and this and all of that. Okay. All right. So again, I always try to do one just straightforward. You don't have to put it in your notes, just kind of hide and watch. So you state your M, state your B. Now my M here, it's there, but it's not there. It's always the number, right, in between the X and the equal sign. Well, there is a number there. It's just not written. What is it? It's a 1, and it's really 1/1, right? Because every whole number can be written over 1. So my M, for movement's sake, I need a fraction. So I have 1/1. My B is -5. Okay, so we begin by plotting our B, which is our Y-intercept. So right on the Y-axis, I put a point at -5. Then I use my M to move. Now I can either move up 1 and to the right 1. Both of those are positive moves, right? Or I could move down and backwards, because 2 negative moves is also a positive move. So if I choose to go positive up and right 1, that's positive, positive. I can do that a couple times, up 1/1, up 1/1. Okay, you don't need this many points, but what if I went down and backwards? Well, down and backwards, notice what happens. Still puts me on the same line. Doesn't change the trajectory of my line at all. And no, you do not need 5 points to graph it. I usually just put them on there as I'm talking. Okay. If your points are super close together, sometimes it's nice to give yourself a couple counts just to get a little bit of space to get a nice straight line. But technically, you only need 2 to graph it. All right, I do want you to put this next one in your notes. It did this to me the other day too. Sometimes it likes to cut off page 2. Now let's go back and go back in and see if we can get it to pop it up. There it is. Don't know why it does that. I want you to go ahead and put this number 5 example in your notes because it's a little unique. Yes. I'm fine as long as you know that it's over 1. And so your run, which is your bottom, your X is always a 1. That's fine. Yep. When you state your M and your B, if you just state it as a whole number, as long as you make your movements right, I'm not going to say anything. All right. Number 5. All right. So hopefully you recognize that this is Y equals MX plus B, right? And when you state your M and you state your B, what's my M? It's the number, right, between the equal sign, which is what? 1/2. Okay, now I need to state my B. Okay, when it's not there, it's there. You just have to know that this right here doesn't change the value of the equation any at all, right? Adding a +0 to the end doesn't change it. I haven't altered the line at all, but I have made sure that I realize I do have a B. Okay, you can't just not have a B. And when I go to plot my B, this is my y-intercept, right? And the 0 y-intercept is right at the origin of the whole graph. And then I use my M to move. Now this is a positive slope, so I can go up and to the right, right? That's a positive move. So I can go up 1 to the right 2. I can do that again, up 1 to the right 2. Or I could go down and to the left because a negative also is a positive. So if I go down 1 and backwards 2, notice I'm still on the same line and I haven't changed my line at all. And I've got a couple of really good points there to make a nice straight line, arrows on both sides. And notice, and it's kind of nice to do, and I haven't really talked about it yet, but it's really nice to do just a last second. I mean, it literally takes you a split second. Look back at your y equals mx plus b, or your M. If it's a positive M, you should be running uphill, okay? If it's a negative M, like this one was, right? If you read left to right, notice our slope here was a -5/4 and our line ran downhill. It's always kind of a nice thing to do, just that last second check to see if you have a negative slope, you should be running downhill left to right. If you have a positive slope, you should be running uphill left to right, okay? All right, so what do we do with one like number 6? Okay, you're told to sketch a graph. I'll give you a second to get it written down. Can anybody tell me what form this is? Logan? Yeah, standard form. And just by its name, right? We don't really get any information out of standard form. You know, slope intercept, we get a slope and an intercept. Point slope, we get a point and a slope. Standard form, we don't really get anything. Now, we did learn last week in indicator 5 that you can cover the X and get the y-intercept. You can cover the Y and you can get the x-intercept. But if we cover the 2y, we end up with what as our x-intercept? Lainey? If we divided both sides by 3, we'd end up with -4/3. You're not going to be able to graph an intercept that is a fraction. So sometimes you can kind of take a shortcut and you can find your intercepts, okay, by covering the X and the Y and finding your intercepts and then graphing your intercepts, which we just did earlier in the video or in today's notes. However, this one doesn't work that way. This one wouldn't work for that because we end up with a fraction. And I can tell you now, you're not going to graph fractions on homework, and Khan Academy won't let you graph fractions either. So you need a different way to do it. Do you guys remember me telling you at the very beginning of indicator 5, with everything linear equation, when all else fails, what? Anybody remember? Yes. Yes. When all else fails, that should be your go-to thought. If you can't figure out anything about a linear equation, your go-to thought should be, what if I put it in y equals mx plus b? Because if you can do that, you can pretty much do anything with a linear equation. So we need to state our m and our b, right? Well, we can't. We have no idea from this. Well, we could find our b. We could cover the x, right? Divide both sides by 2. What do we get? No, if we cover the 3x and we divide both sides by 2, we would get y equals what? -2. So we can actually find our b, but we have no idea what our m is, not in standard form. Standard form does not give us an m. So let's do a little bit of algebra. We're going to minus 3x and minus 3x, right, from both sides. And when we do that, that gives us 2y equals, now on the right-hand side, we have a -3x and also a -4, but I'm going to write those in the proper order. Then I'm going to divide everything by 2, right? Because when I do it to one, I do it to all. And I get y equals -3/2 x. And then -4 divided by 2 is -2. And we already knew that that was going to end up. We already knew that that end number should end up as a -2 because we already identified that our y-intercept was going to be a -2. But what we did get out of doing this little bit of algebra is we were able to get our m, right? So we were able to see that our m was -3/2. And notice the m is just the number, right? It's just the fraction. It's not the x. The x is part of that generic xy. But now, even in standard form, with just a little bit of algebra, we were able to get it into a form where we were able to identify our m and our b. And once you've done that, you're able to start graphing by beginning with your b. So my b here is -2. And then I use my m to move. So in this case, I can either go down 3, 1, 2, 3, and to the right 2, because that's a negative and a positive move. Or I can go up 3, 1, 2, 3, and backwards 2. And you'll notice that either way I do it, I still end up on the same line. And then it's graphed. Okay, so if you need to sketch a graph, when all else fails, think y equals mx plus b. You can always sketch a graph from that. Okay, are we good with that? All right, this one, you don't have to worry about sketching the graph. I just want to talk about getting it put into y equals mx plus b. Okay, because that once it's in graph, once it's in slope intercept, I think you guys have got enough examples in your notes of how to graph it. But I do want you to write this equation down so I can show you something about putting it in mx plus b. So again, I'm going to leave myself a space here because I am going to state my m and my b when I'm done, and that'll help me graph it. All right, so the first thing I want to do is I want to move my x. So I'm going to subtract an x and subtract an x. Now, when I do that, I'm left with -2y equals -x minus 8. Because on the right-hand side, I have a -x and a -8. Now, I'm going to divide everything by a -2, right? Because I want to get that y by itself. This is the part I wanted to make sure and point out. Don't leave that as -x/2 because that does not help you at all to identify your m. You need a fraction separate from the x. So I'm going to split these two apart. What number is really in front of that x, Lainey? It's really a 1, right? It's really -1 over -2. And a -1 over a -2 would give you a positive 1/2. And then the x, and then -8 and -2 divided by -2 is a positive 4. Make sure when you're writing these in y equals mx plus b, don't put this in your notes. I'm just going to write it once the wrong way. Don't do this. Okay. Technically, is that math technically correct? It is, but that is not in y equals mx plus b. You need your m separate from your x. You need them as two separate numbers. Okay. Let me erase that. All right. So now we're going to identify our m here, which now that we have it written nice and neat, our m is right there, 1/2. We're going to identify our b right there. And now, okay, you guys shouldn't have sketched a graph because you didn't need to take the time to do it. So I'm just going to do this really quickly. A point at +4, and then a move of up 1 over 2 or down 1 backwards 2. And there's my line. Okay. So when in doubt, put it in y equals mx plus b. Then you have an m and you have a b. You begin with your b, you plot it, you move with your m. Same thing every time. All right. All right. Now I want to show you one like this, and I don't have a graph for this one either. So we'll start out on this on same footing. So write this equation down, and I'm going to give myself a little graph here. And when I say a rough graph, this is usually what I mean. Don't get too fancy on your notes. It'll take too long. There's actually two ways to do this, kind of like in standard form. I'll wait till everybody gets it written down and then I'll talk about it. Okay, when we had one in standard form, and I'm just going to make one up really quickly, just that I know will work out easy. So if I have one in standard form that is 2x plus 3y equals 6, right? 6 is divisible by 2 and 6 is divisible by 3. So if I just wanted to state my x-intercept and my y-intercept, right? If I cover up my 2x, so I'm just going to cover it up like this for right now. If I cover up my 2x and I divide both sides by 3, I get y equals 2. Everybody agree with me there? Then if I cover up my 3y and I divide both sides by 2, I get x equals 3. And I've just found my x and my y intercept. Very easy math. Don't have to move anything around. Don't have to divide by 3. Don't have to state a slope and an m and a b. You just simply graph a 3 on your x-intercept, a 2 on your y-intercept, like our first two examples, and you're done, right? So there's two ways to do it. Or you could subtract 2x and subtract 2x and get 3y equals negative 2x plus 6. Divide by 3, and get y equals negative 2/3 x plus 2. And then state your m, state your b. Okay, two ways to do it. Same thing with point slope form. Okay, I want to point this out to you. One is always the fallback of what? What's the fallback in case you can't think of anything else to do? Grant, what do you think? What's your go-to for graphing linear if you can't think of anything else? You can always go back to y equals mx plus b. You can distribute. Okay, you would get y minus 5 equals 6 over 5x. And then 6/5 times negative 5 is negative 6. And then I would add 5 and add 5. And I would get y equals 6/5 x minus 1. I would state my m is 6/5 and my b as negative 1. Okay. It's all the algebra we learned last week about how to get different forms in different forms. So then I would start with my b of negative 1, and I would put a point right here. And then I would use my m to go up 6 over 5. So up 1, 2, 3, 4, 5, or up 1, 2, 3, 4, 5, 6, and then over 5, which puts my point about right here. And obviously this is not a perfect graph because it's hand drawn, but that's okay. And then I would graph my line, right? Little bit of algebra, a little bit of distribution, a little bit of multiplying fractions, but it's very doable. The other thing I want to show you is with the same equation, is point slope form, right? Point slope form is y minus a given y equals m times x minus a given x. So if I stated my m here, it's in the m spot, which is 6/5. And I'm given a point, right? My point 1, I'm given. Notice it's just the 5. It's not the minus, because minus is part of the equation. Y minus, you're given y. And then it's x minus, you're given x. So I'm going to leave the minus sign behind, and I'm just going to put a square around the 5 and the 5. So my given point is 5, 5. If I would have done it this way first, right, and not done it over here this way at all, I would have gotten the point 5, 5, which is right here. Okay, 0.55 is also on that line. It all should fall on the same line, because no matter which way you do it, you get correct information. You just get different information. So when we did it this way, we put it into slope intercept form. We got this intercept, and then we used our slope to move. And you can use your slope to move forever and ever and ever. You could move it and you'd be down here. You could move it and be down here. You could move it and be up here, right? You could go on forever with up 6/5, up 6/5, and get a bunch of different points. If we do it the point slope way, we pull out the slope, or the slope, and we pull out the point. It just gives you yet another point on this line. It's not going to give you the exact same points as the other way, but it is going to give you valid points on this line. And since you only need 2 points, if you do it the point slope way, okay, if you do it the point slope way, which is here, you get a point, which is your given point, and then you use your slope to move, and you're still going to get points on this line. Okay, if that confuses you, and this is why I always say this, if this is the second way I showed you, is it's not really a shortcut, it's a faster way to do it, because you don't have to worry about the distribution and the algebra of moving things around. However, if it confuses you, go back to what you know, right? When in doubt, go back to y equals mx plus b. I don't care which, why I show you both. I don't care which way you use. When in doubt, go back to y equals mx plus b. If you can do it a shortcut way and you can keep them all straight, great. If you can't, learn one way and stick with that way to the end, which is always putting it back in y equals mx plus b. When you're asked to graph, that should be your fallback, okay? Your default. All right, so you don't have to put this one in your notes. I just want to, oops, this one. I don't want you to put this in your notes, all right? I just want you to tell me, what's my m here? 3. Okay, now I'm gonna be given a point. Okay, remember that my formula is y minus a given y equals mx minus a given x. For me to get +4, Zane, what would my given y have to be? Nope, because if I just stick a 4 in here, I would have y minus 4, -4. So if you use the method of pulling that point out, you got to remember that your signs flip, because your equation has a negative in it. So if this is a +4 and a +2, first of all, you got to keep them straight, right? It's -2, -4. That's my given point. 2 things you got to keep straight. One is they're in the equation, y and then x, and you need to pull them out, x and then y. And not only do you need to flip them places, why would you grab that? Not only do you need to flip their places, but you need to flip their signs. Okay, so if you use the pull method for your point, that's fine. You just have to remember, when you pull your x and y out, you pull them out, you flip them places, and you flip their signs. Okay, so if I were to graph this, right, I would graph a point at -2, -4, which would put me about down here. And then my slope would be rise 3/1, and that would be my line. Okay, and it's a perfectly valid method, because if I put this in slope intercept form, I think my slope would be positive 2. I mean, my intercept would be positive 2 if I were to distribute and move things around. My y-intercept would be right there at positive 2, right? And then if you used your slope to move, you're still going to end up on that same line. So both methods are valid, okay? Again, I'm not going to work it. I'm just going to really quickly. This one's kind of tricky. What's my m here? It's a 1. And then what's my given point? I heard somebody say 2, 3. You got to remember to flip them. The y's first in your equation. It would be positive 3, negative 2. Flip their places, flip their signs. Now you can graph it. So point slope's really easy if you can remember the shortcut, but if it messes with you, distribute and put in y equals mx plus b, okay? One other thing, and I don't have an example of this, I'm just gonna make one up really quick. What if I have something crazy like this? And I say sketch a graph of that. And you say, holy cow, there is no way, stop. When in doubt, what should you do? Put it in what? Y equals mx plus b. This is no more difficult than if it was in standard form or whatever. You just start moving stuff around, okay? I could move, and there's a couple different orders you can do it in. Okay, there's 2 like this on your homework. This is why I'm covering this. If I move that 3 over, okay, now I'm going to go ahead and get rid of these fractions because I'm not even messing with those at this point. So I'm going to multiply everything by a 2, right? Including this little guy in the middle because everybody gets it. Leaves me x plus 3y equals 2. Okay, I'm almost there. Move my x over. And I get 3y equals negative x plus 2. And then I divide by 3 and divide by 3. Now, I just made this one up off the top of my head, so you come out with a fraction on the b. I promise you the ones on your homework, you will not. But there are 2 challenge ones on your homework. They're the very last 2. They're not in a form you are going to recognize. They're not in standard, they're not in slope intercept, and they're not in point slope. They're just wherever. Doesn't matter. Use what you know how to do with algebra and move it around to y equals mx plus b. Okay? All right. For those of you at home, go ahead and hit load. Show me all your work in Cami. Take notes in your binder and email me if you have any questions.